Good day, learners. Welcome to Technical Sciences lesson. My name is Achilles Chole. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. So today we're going to be looking at the parallelogram of law of forces. So already you have done vectors and scalars. So you know the definition of a vector, which is a physical quantity with both magnitude and direction. And then a scalar, which is a physical quantity with magnitude only, right? And then you are able to give the examples of vectors and scalars, as well as drawing the free body diagram and the force diagram, the resultant and the equilibrant. So the resultant is the single force that has the same effect as two or more vectors combined together. And then the equilibrant is the force which has the same effect as the resultant but in opposite direction. So it simply means the resultant, or the magnitude of the resultant, and the equilibrant, they are the same but they are pointing in opposite direction, right? And then equilibrium of forces in one dimension, as well as the ability to draw vectors using Cartesian coordinate system, compass directions, as well as the bearing method, right? So right now we're going to be focusing at how to use the parallelogram law to determine the resultant of two forces acting at an angle to each other, right? And then after, we have to do how to draw and calculate the components of forces. So let's say maybe we've got a force which is given at an angle with the horizontal. So how do we find the resultant of that force? So we have to use the parallelogram law of forces. Okay, so let's start with our lesson. So vectors at an angle. So sometimes a number of vectors acts in directions that are not perpendicular to each other. And then what do we do in this case? We use the parallelogram law of forces graphical method to find the resultant of these forces, right? So now, the parallelogram law of forces can also be used if the angle between them is 90 degrees, which is the right angle triangle, or it's perpendicular to each other, right? Yeah, so this means that this method can also be used for vectors acting at 90 degrees to each other. It's not only if they are acting at an angle. Even if the angle is 90 degrees, we can still use the parallelogram law of forces. So we know about the parallelogram, especially in mathematics. We have done a parallelogram. You know the properties of a parallelogram, which simply two opposite sides must be equal, right? So those two opposite sides must be equal. So which means we have to complete a parallelogram. Okay. So now, if you are stating the law of parallelogram, the law of parallelogram states that if two forces acting at a point can be represented by adjacent sides of a parallelogram, both in magnitude and direction, then the diagonal from point gives the resultant of these two forces, right? So if you are looking at this diagram here, we've got F1, which is acting at an angle with F2. So we don't know the angle that they are acting on. And then what we know is that we have to complete the parallelogram, right? So we are saying these two opposite sides, they must be equal. And then these ones again, they must be equal. And then what do we do? And then from here, from the origin where you started drawing your first vector, you go straight up until the last corner, right? So, and then that will give you the resultant. So remember, we have done a tail to head method while we're doing the collinear vectors, which simply means we firstly draw the first vector, and then from the head of the first vector you draw the second vector, right? So now in this case, the law of parallelogram, we can simply say we are now using a tail to tail method, which simply means you start by drawing the force F1, which is the first force, and then from the tail of the first force you start drawing your second force, right? And then what do you do after? You complete the parallelogram, and then you draw the diagonal line starting from the origin where you started drawing your first vector, right? From the tail of these vectors up until where you constructed your parallelogram. Then that would give you the resultant force. So if you're looking at the second one, so we've got Fi, and then Fr here, and then there's an angle now which is 45 degrees. We know that if this one is 45, if this angle is 45, which means this one here will also be equal to 45, because they must give you a 90 degrees. So again, you can complete the parallelogram, and then you can simply find the resultant vector. All right. Okay, so let's do this example. So a force F1 of magnitude 500 newtons and a bearing of 90 degrees, and a force F2 of magnitude 400 newtons are exerted on a block. So the angle between the forces, or the angle between these two forces, is 50 degrees. Determine the resultant force exerted on a block by making a use of a scale drawing, which means now you must choose a suitable scale to accommodate these two forces. So F1 is 500 newtons, and then F2 is 400 newtons. So 500 newtons is pointing to the right or east if we are using a compass direction, and then 400 newtons, which is F2, it's northeast, right? So now the angle between them, the angle between these two is equal to 50 degrees. Determine the resultant force exerted onto the block by making of a scale drawing, right? Which simply means you must choose an appropriate scale, and then after choosing a scale, and then you draw the first vector, which is F1 500 newtons, and then from the tail of 500 newtons you draw the second vector, which is 400 newtons in that direction, which is northeast, and then from there you complete a parallelogram, right? And then you connect those two corners, they will give you the resultant, right? So let's see what is expected from us. So now the solution to this, determine the scale. So the scale that you have chosen, it's 1 centimeter is equal to 100 newtons, which simply means if you are using a ruler, the 1 centimeter will represent how many newtons? 100 newtons. So if you are looking at F1, we've got 500 newtons, which simply means how many centimeters if you are using a ruler? It must be 5 centimeters. F2 must be 4 centimeters. Okay, so start after determining the scale, which is 1 centimeter is to 1 newtons. Start from the origin and then draw F1, which is 5 centimeter horizontally to the right, or bearing of 90 degrees, right? Remember, we've done bearing. If we can go back to the bearing method, we are always starting from north, where north is 0 degrees. We've got our north here, which is 0 degrees, and then you move clockwise, right? So this angle here will give you 90 degrees, hence they are saying the bearing of 90 degrees. So F1 of 5 centimeters horizontally to the right, or it's bearing of 90 degrees, right? Then what do we do after drawing F1? So after drawing F1, remember you need to know where is F2. So F2 we must measure 50 degrees from F1, right? So and then you take your protractor, and then you are measuring the angle which is 50 degrees. So these two, F1 and F2, these two forces, they must be at an angle of 50 degrees, right? Not 51 or 49, it must be exactly 50 degrees, so that it gives you the correct answer. And then what do we do from there? And then after measuring the angle, which is 50 degrees, you have to draw F2. So F2 in this case, according to our scale, F2 will be 4 centimeters using your ruler. And then after drawing the F2 in that direction, what do? You complete a parallelogram, right? And then after completing a parallelogram, you now draw the diagonal which represents the resultant force, right? So, and then measure the diagonal line according to, remember you are using a scale which is 1 centimeter is to 100 newtons. So you take your ruler, you measure how many centimeters is that diagonal line. If the diagonal line is 6 centimeters, then that 6 will give you 600 newtons. So which means the resultant for this is the same as 600 newtons. So, and then after measuring, and then you measure the angle again. So in this case, our angle, it's 65 degrees. And then now you write your final answer. So where is this 65 degrees coming from? So remember, now you have to draw a diagonal line, right? Diagonal line. Again, now starting from north, which is 0, using a pairing method, you are measuring now the angle between 0 degrees and this line, which is the resultant force. So now this angle here will be equal to 65 degrees, right? So not that 50 degrees now. So you are measuring now the angle or the direction of the resultant vector, starting from 0 degrees where it is north, and then you move clockwise direction up until to this line, which is the resultant vector. So now that angle will give you the direction of the resultant vector, right? So now if we are measuring this angle, we got a value of 65 degrees, which simply means our net force is equal to 790 newtons, bearing of 65 degrees. So if you are using a ruler, which means you got 7.9 centimeters, right? Remember, now we said 1 centimeter represents how many newtons? 100 newtons. So this 7.9 centimeters, you simply multiply by 100, and then it's going to give you 790 newtons, right? So now remember, this one is the magnitude together with SI units, right? So you need to include the direction. So according to the pairing method, we can simply say pairing of 65 degrees. What if we're using a compass direction? So you check the direction using a compass. It's going to be northeast, right? Remember, if you are using a compass, you've got north here, you've got east, and then you've got south and west. So if the line is between north and east, it's northeast direction, right? Okay, so now let's move on to this exercise. So exercise number 1, by making use of the parallelogram law of forces, draw vector diagrams not according to scale to indicate the resultant for the following forces, which simply means you should not use a scale. So just draw the resultant force, right? Okay, so if you are looking at A, so this is our first force, which is A, which is pointing north, and then B, which is pointing east. Remember, you are drawing the first vector, which is A, and then from the tail of the first vector, you draw your second vector, right? Okay, so what do we do after? And then now we have to complete the parallelogram. Remember, the parallelogram, the two opposite sides must be equal. So these two sides, they must be equal, right? It shouldn't be a rhombus, it must be a parallelogram. So, and then you start drawing from here up until to that corner. It's going to be your resultant vector, right? So, and then you can now measure the resultant vector using your ruler. You take your ruler, you place it here, and then you check how many centimeters. So in this case, we are not using a scale. We just have to complete the parallelogram and then show the resultant vector. So as you can see that the angle between A and B is 90 degrees. So now what will be the angle between A and the resultant vector, right? So this angle here, again, you have to measure using a protractor. Let's say maybe the angle will be 45 degrees. If the angle is 45 degrees, then you know that the direction of the resultant, it's bearing of 45 degrees. Okay, so now let's check this one. 1.2. So 1.2 now, the only thing that they've done is to reduce the angle between A and B. So now the angle between A and B is no longer 90 degrees, right? Okay, so now what do we do from here? Or how can you draw the parallelogram, making sure that those lines are equal, right? You can simply just put a cross here, small cross, and then after measuring this angle, let's say the value of this angle is 65 degrees. I'm making an example. So if this one is 65 degrees, and then you come here, you place your protractor here, and then you check this angle, it must be 65 degrees. And then you draw your line here, and then again this one here. So now your parallelogram now is complete. What do we do then after? You have to connect these vertices from here straight up to where you were drawing your parallelogram. So this will give you the resultant force, which is Fr, right? Okay, so now again, the direction of this, again, if you are measuring using a bearing method, you just put a line here, and then you start counting from 0 degrees, which is north. You go straight to this line here, and then you check the angle between that. It's going to give you the resultant force together with the direction. Remember, it has magnitude and the direction, right? Okay, so now in number 2, they said determine the magnitude and direction of the resultant force in each of the following cases by making use of a scale drawing. So now you must choose a suitable scale for these two forces, right? So we've got 34 newtons as well as 50 newtons. So what can be the scale of these two forces? So this is 2.1. Remember, we've got 50 newtons and 34 newtons. We've got 50 newtons this direction, and then we've got 34 newtons pointing downwards, right? So now let's choose the scale for this. So you can simply say, remember, a scale you can be chosen using centimeters or millimeters. So I prefer if you are using the centimeters. So 1 centimeter is equal to, let's say, 10 newtons. So 1 centimeter represents 10 newtons, right? Okay, then what do you do after? You have to complete the parallelogram, right? So this one here will be the same as 5 centimeters using the scale. So again, you draw your 5 centimeter here using your ruler, and then the angles must be equal, right? Okay, and then what about 34 newtons? It's 10, 20, 30, which is 3 centimeter, 3,4, right? Would give you 34 newtons. So again, you draw using your ruler for 3.4 centimeters. So this now gives you a complete parallelogram. Two opposite sides are equal. And then what do you do next? We draw your resultant starting from this corner here straight to this one. So this would give you your Fr, which is your resultant force, right? So now what do you do after finding the resultant force? Again, after finding the resultant force, you can simply place your ruler on top of this line. You are measuring how many centimeters does the line represents. So if it represents, let's say 10 centimeters, then the resultant will be equal to 10 centimeter multiplied by 10 newtons, which gives you 100 newtons, right? So this will be 100 newtons. And then what about the direction of the resultant? Again, using a bearing method, you can simply throw here, but this line must be, the cross must be invisible, right? We shouldn't see that cross. And then you place your protractor here. You start counting 0, 90, up until this angle here. So that angle will give you the direction of the resultant, right? Okay, so now let's move on to 2.2. So again, what are we doing here? We're just finding the magnitude and the direction of the resultant force in each of the following cases by making use of a scale drawing. So in 2.2, what happens in 2.2? So you've got 72, the angle here, which is 72, and then this one here is 39 degrees, right? Okay, so we've got 125 newtons as well as 110 newtons. So now 125 newtons and 110 newtons. So it's 125 newtons, 110 newtons. The angle here, let's check the angles. So you've got 72 and 39. So this one is 72 degrees, and then we've got 39 degrees here. Then what do we do? You have to choose the suitable scale to accommodate 125 and 110 newtons. So your scale, you can simply say 1 centimeter is to 10 newtons again, or you can simply say 20 newtons. So let's choose 10 newtons, which means we're going to have a long line here, or long lines. Okay, so you firstly draw your first vector using your ruler and a protractor. So you put a cross here, you start drawing 125 degrees, right? So remember the angle, it's 72. So it's going to be in this direction. You are drawing using a scale, which is 1 centimeter is to 10 newtons. And then after that, you draw what? You draw your second vector, which is 110 newtons at a bearing of 39 degrees. So again, it's going to be here. So this will give you 110 newtons if you are using a ruler, right? Okay, so now this 39 degrees, remember, it's just the angle. This 39 degrees is the angle from this line up until here, right? Don't forget that. Then what do we do after? You have to connect or draw a parallelogram. So if you are completing using a parallelogram, again, you're going to draw this one here, and then this one. So now your parallelogram is complete. Then what do we do? Starting from this point to here is going to be your resultant force, which is Fr, right? Then after, you measure the angle, or you start by measuring the line. It's up to you. So you place your ruler on top of the line, you measure how many centimeters, you multiply by the 10 newtons as we have chosen from the scale. And then again, you can measure the angle between here up to here. It's going to give you the direction of the resultant using a bearing, right? Okay, number 3. In 2.3 now, the force is given in kilonewtons. Alright? So now, remember, if we are doing the calculations, we have to convert from kilonewtons into newtons. So in this case, we are not going to convert, but how do you convert? You simply multiply it by 1000. So it's going to be 4000. So this 4 kilonewtons is the same as 4000 newtons. And then here you've got 2000 newtons, because you are simply multiplying by 1000. So the angle between the line here is 25, and then this one is 30 degrees, right? Which means the angle between these whole two lines is going to be 35 plus 25, which is 55 degrees. Okay, so again, we've got 4 and 2. You can choose your scale. The scale is, we can simply say 1 centimeter is to 1 kilo newtons. If you are using the newtons, you can say 1 centimeter represents 1000 newtons. So in this case, we are using kilonewtons. So that's why we are saying 1 centimeter represents 1 kilonewtons. Okay, so now if you are looking at the angle between the line and 4 kilonewtons is 30 degrees, right? And then this one for 2 kilonewtons is 25 degrees. So again, you throw your first vector here. So if you, let's say maybe you are using a pairing method to draw these two lines, right? So remember the angle, this 30 degrees is just the angle from here, not starting from, so if this one is 30, which means this will be 60 newtons, right? So you can simply take your protractor and then place it here, and then measure the angle 60, and then you draw your line using the scale. So after that, what do we do? Again, this one here for 2 kilonewtons, again, if you are starting from 0 up to this point, it's going to be 60 plus 30 plus 25, which is 115 degrees. And then you come here, you place your protractor again here, starting from, you're counting from 0, which is your north, up until 115 degrees, and then you draw your second vector, tail to tail method, right? Okay, so our second vector should be in this direction. Then what do you do after? You have to complete the parallelogram. So by completing the parallelogram, these two lines must be equal, and then, so mine are not equal now. So you can simply use the same process that you have done using a pairing method. Then you complete, or you draw the diagonal line. It's going to give you the resultant vector. So this would be your FR, which is the resultant vector, right? Okay, so what about the direction? Direction again, you can start from here up until this line. You measure using your protractor. Remember here it's 0 degrees, and then you measure the angle until the resultant vector is going to give you the direction of the resultant using a pairing method, right? Okay, so that's how we do the parallelogram law of forces. Remember how to state it, because it is very important to state. You must be able to state this law. If two forces acting at a point can be represented by adjacent sides of a parallelogram, both in magnitude and direction, then the diagonal from the point gives the resultant of two forces. So this is going to give you 2 marks. Okay, Now let's move on to component of vectors, right? So component of vectors, remember a force. Let's say you've got a vector which is given at an angle. So if you've got a vector which is given at an angle with the horizontal, that force, it has two components. There's a vertical component and the horizontal component. So the lawnmower here is pushing, and then there's this force which is pointing to the right. This one it's a vertical, it's a horizontal component, and then here you've got a vertical component. Remember, he is applying a force in this direction. So I'm not sure if you're going to see, but the guy or the lawnmower is applying a force to this direction. So now this direction is applied at an angle, which simply means it has two components. There is fx component, which is the horizontal component, and then there is a vertical component. So components of vectors are vectors that act, or vectors that together have the same effect as the original vector. So now this here is your original vector, the one that I've just drawn now. This is your original vector, and then it has two components, which is the vertical component and a horizontal component, right? So let's say maybe you are having an applied force here, and then how do you draw the component of these forces? It's going to be the vertical component and then the horizontal component. So we've got a vertical component and a horizontal component, right? So as you can see here, when you push a lawnmower along the ground, the force you applied on a handle of a lawnmower both pushes the lawnmower vertically down onto the ground and moves the lawnmower horizontally forward, right? Okay, so now vertical and horizontal component of forces. A force acting at an angle with the horizontal can be split into two components, namely vertical component as well as the horizontal component. So you've got a vertical component and a horizontal component. So let's say you've got a force here again. Maybe the angle is 60 degrees. So this force is acting at an angle of 60 degrees with the horizontal. So how can we draw the vertical component and the horizontal component? So the vertical component will be in this direction, pointing vertically upwards, and then here you've got your horizontal component. You've got a horizontal component. So these components can be found by scale or by graphically, and then you can use the calculations. So if you are using the drawing method, you can simply use a scale, switchable scale, and then you draw this component using your ruler, and then it's going to give you the size of the components. Okay, so the magnitude of the component of forces can be found by a scale drawing or by using a calculation. A scale drawing, okay, of course you have to use the parallelogram law, is used to resolve a force into its components. And then you can also use the trigonometry ratios learned in mathematics to resolve a force into components by calculation, right? So, and then if you are using the calculations, how to calculate the horizontal component. So a horizontal component is we can calculate it by using this formula here. Fx is equal to f sine theta. So this fx is going to be the horizontal component. So horizontal component is equal to the f here, it's the actual force. So F is the force which is given, and then the sine 30 is the angle between the force and the horizontal. Alright. Again, if you are using the vertical component, you can simply use Fy is equal to Fy is equal to F cos theta, right? So there's a few mistakes here. Let's just correct that mistake. If you are calculating the horizontal component, you have to use this one. So it's Fx is equal to F cos theta, right? So for horizontal component, please correct that one. It's Fx is equal to F cos theta. And then for vertical component, vertical it's Fy is equal to F sine theta, right? So for vertical component, you are using Fy is equal to F sine theta, but for horizontal component, it's Fx is equal to F cos theta. So just remove this sine theta here. The sine theta belongs to the vertical component, and then the horizontal component, we've got cos theta, right? Sorry about that mistake. Okay, so let's see the examples that are given to us. Calculate the magnitude of the x and y components of 250 newtons force acting at 30 degrees to the horizontal. So the force that is given here is 250 newtons, right? So it is acting at an angle of 30 degrees with the horizontal. Then how do we find the x component, which is the horizontal component? So we are going to say Fx is equal to F cos theta, which is our equation, and then F is 25, or it's 250 cos 30, and then after that you punch your calculator. 250 cos 30 would give you 216.5 newtons horizontal. So the direction is horizontal, right? So this 216.5 newtons is the magnitude. So that's how we calculate the x component, or the horizontal component. Moving on to the vertical component. Vertical component, remember we are saying it's Fy is equal to F sine theta. So our F is the force which is given, 250 sine 30. So sine 30 is half. So half of 250 is going to be 125 newtons vertical, because now this one here, it's a vertical component, right? So just correct that mistake from here. From this one here, we've got Fx is equal to F cos theta, not sine theta. And then for Fy, it's Fy is equal to F sine theta. So here we've got sine theta, we are cancelling this one. And then you've got cos theta, right? Okay, sorry about that mistake. So now let's do this exercise. The diagram below represents three forces that act at the same point, which is point O. The magnitude of F2 and F3 are 30 newtons and 20 newtons respectively. The vertical and horizontal components of F1 are 8 newtons and 6 newtons respectively. So in this case, we are given the F2. So F2 is 30 newtons, and then F3, which is 20 newtons, right? Okay, and then we don't know the force F1. F1 is not given, but what do we know is the components of these two, or of F1. So the components of F1 is Fx, horizontal component, and a vertical component. So the vertical component is 8 newtons and the horizontal component is 6 newtons, right? Okay, so the first question, define the term resultant vector. So resultant vector, we are saying a resultant is the single vector that has the same effect as two or more vectors. That has the same effect as two or more vectors together, right? So we are basically adding all the forces acting on an object. It's the same as the sum of all forces acting on an object. So now let's go to 2.2. 2.2 is a force, a vector quantity. So you can answer by saying yes or no. So we know that a force, it has both magnitude and the direction. So if it has magnitude and direction, which means we can simply say yes. So force is a vector quantity, right? Okay. So are the forces in the diagram above collinear or coplanar? Remember, we've done collinear vectors and a coplanar vectors. We said collinear vectors, those are vectors that are acting in the same line, and then coplanar vectors are vectors which are acting on the same plane. So if you are looking at these three forces here, we've got F1, which is acting at an angle of 50 degrees with the horizontal, and then F2 is acting at an angle of 90 degrees according to the bearing method, or it's simply acting pointing east direction. And then you've got F3, which is 20 degrees, right? So are these forces collinear or coplanar? So if you are looking at them, they are not from the same line, right? So we can simply say, by looking at these vectors, those are coplanar. So the answer for 2.3, it's coplanar. And then calculate the following, or the magnitude of the following. So now, if you are calculating the magnitude of F1, they're simply saying find the size of F1. How can you find F1? So F1, we don't know the value of F1, which is the one that you are looking for, but what do we know? We know the X component and the Y component, right? So the vertical component, it's 8 newtons. So what do? You write your equation for vertical component, which is Fy is equal to F sine theta. Okay, so now they said Fy is equal to 8, and then what about F? So this is the F1 that we are looking for, right? What is the angle? The angle is 50 degrees. So its angle is 50 degrees. So it's going to be F1 sine 50 degrees. So remember, we're just doing the components, how to calculate Fx component, which is the horizontal component, and then Fy, which is the vertical component. So now in our questions, they gave us that component, which means we need to find the force, right? So you can choose, since you've got the Fx component and the Fy component. So let's just do both and see if we've got the same answer. So what do we do from here? Since you are not looking for sine 50 F1, you can simply divide by sine 50 degrees on both sides. So if you are dividing by sine 50 degrees on both sides, this one will cancel this one. What is the value of F1 according to this component? The value of F1 should be 8 divided by, you can punch your calculator there, 8 divided by sine 50 is going to give you 10.44 newtons. So this here is 10.44 newtons. All right. So now the direction of this one, it's vertical. So the direction, it's vertical, which means the force F1 is equal to 10.44 newtons, right? Okay, so now remember, you've got X component and the Y component, so you can choose which one are you going to do or to use, right? Okay, so now let's go to 2.2. In 2.2, they are simply saying calculate, in 2.4.2, calculate the magnitude of the vertical component of F3. So if you are looking at F3, this is our F3 here. Now we have to find the vertical component of F3. The vertical component of F3. Okay, so now the vertical component of F3 will be in this direction. So the angle here, it's 70 degrees, right? Yeah. So this is going to be Fy is equal to F3 sine theta. Then what is our F3? Our F3 is equal to 20 newtons. So you've got 20 sine 70 degrees. So 20 sine 70, it's going to give you 18,79 newtons vertical. So your answer will be 18.79 newtons vertical. So maybe let's go to 2.4.1 and see if we have done everything correct. So if you are looking at 2.4.1, the angle between F1 and the horizontal is 50, right? So which means we're supposed to use this angle here, which is 40 degrees, not 50 degrees. So instead of saying sine 30, we have to say sine 50, we have to say sine 40 degrees. So you divide by sine 40 degrees and sine 40 degrees. Now your answer will be different. 8 sine 40 degrees is going to give you 12.44. So the answer is 12.44, sorry. 12.44. Let's say maybe, let's see if we get the correct, the very same answer if we are using fx. Fx is equal to f1 cos theta. So now this will be 6. Our f1 is the one that you are looking for. So now we have to use cos 50 now. We have to use cos 50 and see if we get the same answer. You can do that at home. Divided by cos 50 degrees should give you the same answer. Okay, so thank you so much for attending. See you on the next lesson. Thank you.